Okay. So you guys are going to be super psyched about this lecture. It is going to be, whoops. These are notes to myself. So you guys are going to be super excited because this lecture is going to be very, very short. Because it's something you sort of already are aware of. It's that during a chemical or physical change, mass remains constant. Now, you've probably heard this as matter cannot be created or destroyed. That's essentially the way we're going to think about it. Is mass cannot be created or destroyed. Therefore, and this is the key point to conservation of mass and why we're doing a whole lesson on it when I could have just told you briefly. The number and type of atom present at the beginning of a reaction. Remember, these are called the reactants. Must be present at the end of the reaction, which is what we call the products. So if I have a chemical reaction where or let's even say a physical change, one of the ones we talked about extensively. If I have 10 molecules of carbon dioxide at the beginning, well, I must have 10 molecules of carbon dioxide at the end. Well, let's just say I do something differently, where I have H2, I'm going to give you a little sneak preview here, plus O2 makes 2 H2O. Well, if I have 10 of these hydrogen molecules, 5 of these oxygen molecules, at the end, I still will have 10 hydrogens. Sorry, I don't want to do it exactly that way. Let's do 20 and 10. And say 20 hydrogen atoms, 10 oxygen atoms. At the end, it's still going to have 20 hydrogen atoms and 10 oxygen atoms. So this is going to allow us to actually balance our chemical equations. Because if I know what I have at the beginning, I know that same number and type of atom has to be present at the end. Otherwise, I'm violating conservation of mass, which we cannot do. So there's some longer amounts of summary today. How does mass change during a chemical or physical change? Individual atoms are conserved. So the number of atoms of each element remains the same from start to finish. The total mass of the products equals the total mass of reactants. And you guys saw that today. Now, if I have an open container and I'm making a gas, it sort of looks like I'm losing some mass, right? But those atoms aren't disappearing. They're just going into the room. And we're really not, we're not weighing them anymore, right? So we're not taking that into account in our mass. So matter is conserved. Neither matter cannot be created or destroyed. This is something you know. And this idea that gases have mass. I think this is something you guys are all aware of, but I just want to hammer that home a little bit more. So gases do have mass. There you go. Nice and short.